Hey guys, I'm wearing my magician's hat. It's Houdini time. Welcome to another very exciting tutorial. In this tutorial, I want to introduce you to working with physics in SideFX Houdini. SideFX Houdini is a very powerful but also pretty complex procedural 3D software package that is gaining more and more traction in the visual effects industry. Now, while physics in general can seem quite daunting, working with physics in Houdini can seem downright scary. But we will take it nice and slow, so this is going to be a mid-level beginner tutorial. I will, however, assume that you have at least watched my absolute beginner tutorial on how to use SideFX Houdini. If you haven't yet, punch! But now, before anyone else gets hurt, let's jump right into the tutorial. Welcome back to Houdini. I've got a brand new project set up here, and you won't need anything at all to follow along with this tutorial other than your own version of Houdini installed on your computer. Also, note that while I'm using the indie edition of Houdini, you will not have any problems at all following along with the free apprentice version. Before we get into the physics, and for reasons I've already covered in my last Houdini tutorial, I'm first going to come up into the main toolbar and switch my desktop from build over to the technical desktop. This is going to add a whole bunch of new UI elements, but we are going to need them to really understand what is going on in our scene later on. For now, I'm simply going to come to the bottom here, and I'm just going to collapse this additional toolbar just so I see a little bit more of my viewport, and let's get into it. Let's start out by creating a simple box, so we can simply come up into the shelf tool, onto the Create tab, and hold down Ctrl on your keyboard and click on Box to create a box in the center of your scene. There's our box. Let's zoom out a little bit, and I'm going to drag this box up a little bit. I'm also going to rotate it just a little bit so that when it does drop, it drops a little bit more interestingly. Then come down to the main timeline control at the bottom of the interface, go over to the right hand side and enable this little clock switch here, which enables real-time mode, so your playback will be in real time. Otherwise, Houdini will just race through this as fast as it can. Make sure you're at the very beginning and simply hit play. And it's absolutely fascinating and not at all surprising that nothing at all is happening, because all we have in our scene is a simple box. If we go over into our scene view, and again I'm just going to make this a little bit bigger, all we have is this little box object here. And if we dig into this geometry node, all it contains is a simple box, which we're seeing here, and that is really all we have in our scene, so there are no physics as of yet. As is the case with absolutely anything in Houdini, you could set your entire physics simulation up manually. However, for entry-level users, I highly recommend just using the shelf tools at the top. So on the top right-hand side, you will find a tab for rigid bodies. And in here, you have a whole bunch of controls to create RBD, rigid body dynamics objects, glued objects, instancing, ragdolls, grains. You can make things destructible. There is a huge set of presets here that you can apply. So let's come over all the way to the left side. Make sure you have your box object selected in your scene view. And let's simply click on this little cute rubber duck here, which says RBD Hero Objects. Let's hit that. And you may notice that our box has disappeared. That is because we are already at position 79 on our timeline. So the box had plenty of time to simply fall down. Let's come down to the very left side and just rewind our entire scene. And now if we play this back, the box will fall. Obviously, this still isn't terribly much more exciting than what we had before, but we actually have a physics simulation now happening in our Houdini scene. If we go into the scene view, you will now see that Houdini automatically added a new node called an auto-DOP network. DOP stands for Dynamic Operations, and this network is responsible for managing and calculating the physics in your scene. Let's double click onto this auto-DOP network and check out what's inside. I'm going to again make this a little bit bigger, otherwise this will be a little bit difficult to see. Press L to lay out all your nodes and H to zoom in. And this is our dynamics operator network. At the very top we have our rubber duck, and this is the RBD object. This node essentially imports the geometry, our cube, and I will show you how that ties together in a second, and creates an RBD object. This object is then capable of interacting with the physics solver, which is essentially the brain of the operation. It's essentially the tool that calculates how the physics is being applied to your objects. Now, one thing you will notice that when you're using the shelf tool, Houdini does add a lot of default nodes that aren't actually used. So for example, the RBD object right now goes into a merge node where you can chain other objects into. We don't actually need this merge node for now, but I'm going to leave it. It's essentially just a pass through at this point. But the one important thing, the most important part of this entire auto-DOP network right now is the rigid body solver. This is a solver for rigid body dynamics. Now, whenever you hear the word solver, and this took me a little while to understand, it's actually really simple. The sole purpose of a solver within Houdini is to calculate the state of something at the current frame based on the previous frame. So it's essentially a sequential calculation. And the purpose of the rigid body solver in specific is to calculate the state and the position and orientation of all of your physics objects within your scene for the current frame based on the previous frame. You can see that our RBD object, which is our box, is fed into the solver. So the solver will now calculate the state of the box at frame number 1 based on the previous frame. Obviously, there is no previous frame, so it doesn't actually have to do anything. But if I move forward, if I now scrub forward a little bit, you will see that the box falls. And at frame 17, this solver will take the data from frame 16 and calculate this particular frame. That's why when I jump, for example, to 144, and you can see nothing has been buffered here, this solver will have to solve all of the frames between 17 and 144. So let's click here. And see how everything is now blue? It's because the physics solver actually had to calculate all of these frames because it can't calculate frame 144 without frame 143. It can't calculate frame 143 without 142, and so on and so forth. The reason that is so important is because that is really essentially how any solver works, and that is true for physics, for fluids, for cloth, for fire. They all use solvers that always calculate the current frame based on the previous frame. So that's really the brain of this physics operation. The output of that is essentially just physics data. It's not actually the box itself, it's just physical data that gets output. That then again flows through a merge node where nothing else is feeding in yet, so it's just a pass through. It then flows through this gravity node, which, what a surprise, calculates the gravity on top of the physics, and it then feeds into this output node here at the bottom. You may wonder that, well, if this is just a physics object, so this doesn't actually represent the box, and my output is just physics data, how does the box actually move? How does Houdini know to move this geometry node based on the physics data that is tracing through this network? This actually took me a while to understand, and the easiest way to explain this is to look at our hero object, at the box object that we're importing. If I bring up the properties, it has a sub-path, a surface operator path, which points to some geometry that gets imported into this network and turned into an RBD object. This path, very much like a file system path, points to /obj /boxobject1 /dopimport1. And as I've covered in my previous tutorial, this is a path that refers to a node within your Houdini network. In the technical desktop, and again, that's why I love it, on the left side we have a tree view, and in here we can now find this element. So I can find root object, boxobject1, dopimport1. And if I select this, and let's press L and H to make sure we can see everything that is inside this boxobject1, and you will notice that, well, we had the box in this node before, but now Houdini has actually added a rest node and a dop import node. The rest node is not that important in our scene. It actually just helps kind of make the material stick to the bodies as they move and transform. So it just calculates a rest position and adds a property to this data. But then there is this dop import node. This node is responsible for interchanging physics data with our AutoDOP network. The inputs into this node is what's being fed into the AutoDOP network. The AutoDOP network then will process the data, and at the output of the AutoDOP network, that data flows back into this node. And this node then does something to the geometry within this scene. And what it does, down here at the bottom, there's an import style, so that refers to the way the data from the AutoDOP network flows back into this particular box object 1, we're transforming the input geometry. So this node actually takes the output of our AutoDop network and it applies it to our box object. So that's why when we play through our scene, the box falls. If I go back to the beginning and if I bypass this DOP import node and if I now play back my scene, my box will no longer move because I'm no longer exchanging data with the DOP network. So the data is no longer flowing into the network and the calculated physics position and data for this box no longer comes back onto the geometry. Let's disable the bypass again, rewind, and let's play this back one more time. And again, the box will fall. Now let's spice up our scene just a little bit by adding a ground plane. Let's come back to the object level, and you can create a grid itself and turn that into a static RBD object. What I prefer to do is I can come up into my shelf tools, and over on the right hand side you will find a collisions tab, and in here you will find a ground plane object that you can just create by holding Control and clicking on it. So now we've created a ground plane, and here's our ground plane object in our scene view. And now if we jump back into this AutoDop network, it's gotten a whole lot messier. Again, let me make this a bit bigger, L and H, so we can see what's going on. And on the right hand side, you'll remember our rubber duck, the rigid body solver, and the gravity node. On the left side, we now have this ground plane object. And again, this is just a Houdini node that represents the ground plane in our world as a physics object, so it can interact with the physics in our scene. Again, goes through merge node, we can ignore that. And it then goes into this static solver. Again, remember, a solver is just something that calculates the state of the current frame based on the previous frame. The purpose of the static solver, quite honestly, is to do nothing at all. It doesn't actually modify or calculate anything. It's just used as a pass-through, but it becomes useful when you're trying to blend or switch between different solvers. And then what happens is that this ground plane gets merged with the output of the rigid body solver. So this actually merges the physics data between our moving object and the ground plane, which is absolutely static. Then obviously we still apply gravity and then output the whole thing. So now if we rewind our scene and play this back, the box falls onto the ground. These DOP networks are really the fundamental way in which Houdini applies physics, and there is a lot more to it that I haven't even touched yet, obviously. But I hope you do start to get a feel for how Houdini deals with physics, especially this whole DOP import and export thing that happens to apply the actual transformation onto the node, which is what essentially makes the box drop in the end. So these networks really just generate position and transformation data that you then have to backwards apply back onto your geometry to make things actually move. Obviously, by using the shelf tools, a lot of that plumbing will be set up for you automatically, but there's nothing stopping you from just doing it all manually, if you're so inclined. Now, if you check out our scene one more time, this is not terribly exciting, so one thing you might want to do, for example, is give your objects a little bit of initial velocity so they don't just, drop like a dead body onto the ground. If you want to do that, you actually have to do that inside the AutoDop network where you're importing your geometry and turning them into an RBD object. So let's select our RDB box object 1, so our hero object node. Let's bring that up. And this node is just an RBD object node. There's a huge amount of settings here that you can adjust, and I won't go through them all. Obviously, with Houdini, you can always come up to the top right hand side and click on this little help icon, and it'll bring up the Houdini help, which will explain what this node does and what all of these settings do. The main ones I'm interested in now is, well, obviously SOP path. We already explained this. So this is the DOP import node where the data comes from and where the data goes back to. And at the bottom, you will find a tab for initial state. This is where you can define the initial state of this RBD object that represents the actual cube in our scene. You can move its position or rotation. The two things I'm more interested in is you can give it a velocity or an angular velocity. So for example, right now our cube simply drops to the ground. But what I can do, you can see the axes here, Z, Y, and X. So let's give it a bit of a push in the X direction. So it's going to fly off to the right hand side. So let's simply come into our RBD object within the AutoDop network, go into the initial state tab, and maybe we'll give it an initial velocity of 6. Again, make sure you're at the very beginning, and let's play this back. And you can see the box is now being tossed over to the right hand side. We can also give it some angular velocity. So for example, let's give it a velocity of 50 in the Y direction. Again, let's rewind and play this back. By the way, In order to play back and stop your timeline in Houdini, simply use the up arrow, so up arrow to play. And you can see the box is rotating a little bit. Let's stop this again, rewind, and let's give it a little bit more. Maybe we'll make this 120, and let's play this back. And you can see the cube spins as it flies away. So this initial state gives you a way to define how your objects are going to move from its starting point. Let me scooch this over a little bit so we can see our scene just a little bit better. The other properties you likely want to modify for your physics simulation is obviously how these objects interact. So right now the cube has a very clear way of dropping onto this ground. But there are certain physical properties like friction, bounce, that do govern how this interaction happens and how this movement looks. In order to adjust those ones, make sure you still have your RBD object selected in your scene view within the AutoDOP network. And in the settings, under physical, at the very bottom, you will find a whole lot of physics properties that you can change. You can change the mass, you can change rotational stiffness, the bounce, or the friction, temperature, a whole bunch of other settings that will affect how your simulation plays out. So for example, let's reduce the friction to 0, which means the cube is going to be treated as if it was ice. So it's going to have a very, very low friction. Maybe I'll rotate the camera a little bit because I do expect this cube to scoot along the ground for a fair bit. So let's play this back. And there you go. Can you see it sliding? It's essentially like the cube is being treated like ice. Whereas if I rewind and jack the friction up to maybe 5, so it's like a really rough surface that's going to stick quite quickly. And now play this back. You can see the cube hardly spins, it hardly moves, it just kind of stops where it lands. Now that we've covered some of the basics of how to work with physics in Houdini, let's have some fun. Let's come back up to our object level. I'm going to rearrange a few of these panels. Let's zoom back in, and I'm actually going to delete my box object. I just want to leave the ground plane. Let me scoot this over a little bit again and kind of center our scene. Also don't need to see quite as much of the tree view. And let's create a huge amount of spheres that just drops out of the sky and lands on the ground. Before we do that though, however, I do want to make one quick note. You may have noticed that I just deleted the box from my scene view. However, if you go into your AutoDOP network, you can see that the import for my box object is still there. My merge and my rigid body solver are still here. And I can still see the cube. That is weird. What's going on? So there's still now it's gone. I'm confusing Houdini because I've actually deleted a geometry node, but I haven't actually removed the rigid body part out of my AutoDOP network. A much cleaner way of doing this rather than deleting your geometry node. Let's come back to the object level and let's undo to get our cube back. And there it is. And now instead of deleting this box object because it is part of the physics simulation, what I actually want to do is I want to come up over on my right hand side in my shelf tool. There'll be a Drive Simulations tab. And in here you will find a button to remove object from simulation. And so make sure that your box object is selected, and rather than just hitting delete, just use remove object from simulation. So let's click that. This is now highlighted, the RBD object node in our AutoDOP network that we want to remove. Now either press enter or click the button one more time. And there you go. So we've now removed this box object from the simulation. It's kind of trimmed down the tree of our AutoDOP network. The ground plane is still there. That's still valid because it's still part of our physics simulation. Let's return to the object level. And now we can delete our box and everything is nice and clean. But now enough dabbling around. Let's get to the fun part. Now in Houdini there's always a million ways to do the same thing, so you will have to bear with me through my newbie way of approaching this. But what I'm going to do is I'm going to come into my scene view, simply right click, and let's search for the geometry node and place down a geometry node. Because what I want to do, I want to create a large number of spheres floating in midair that will then all be affected by physics and scatter onto the ground. Let's double click onto the geometry node to jump into it, and I'm going to delete the default file node. And let's create a simple sphere. Now I am going to move the sphere quite high up and maybe zoom out a little bit. And I'm going to use this sphere to essentially distribute a whole bunch of other spheres up in the air. So let's increase the radius of the sphere to 10 by 3 by 10. So we kind of have a little bit like a giant Smarties hovering over the ground. Next, let's click onto the output connection. So we have an output actively connected. Let's hit tab to bring up the node menu and let's search for the scatter node. Let's select scatter and drop that down. And if we visualize that, the scatter node will distribute points along the surface of the object. So we now have a whole bunch of different points floating in midair, which is kind of cool. Now let's create another sphere, and what we're going to do is we're going to essentially use another sphere, or you can use any other object, and copy that onto all of the points that we've created. So let's just hit Tab to create a new node, and again let's lay down a sphere. So here's our other sphere. I'm actually going to leave it at the default position. Let's just quickly visualize it, and I actually might change the radius to 0.2, 0.2, 0.2, so it's a little bit smaller. And in order to copy this sphere onto all of these points, we're going to use a CopyToPoint node. Let's hit Tab and search for the CopyToPoints node. Let's place this in our network, and this node takes two inputs. On the left side, if you hover over this, it's the primitives to copy, and the one we want to copy is the sphere, so I'm going to grab the output of the sphere and feed that into the left input of the CopyToPoints node. And on the right side, if you hover over this, it'll say target points to copy to, and I'm going to take the output of the scatter node, which are all these points that are floating in midair, and connect that to the right side of my CopyToPoints node. And now if I visualize that and zoom in, you can see that I now have this sphere copied to all of the points that I've created. To me, it does look a little bit too uniform though at the moment, so I'm going to move my scatter node over to the right side, click onto the connection between the scatter and the CopyToPoints, and let's search for a point jitter node. Let's place that down, and the point jitter does exactly that. It kind of jiggles these points around, and you can kind of define how big you want these to kind of spread out, just so they distribute a little bit more randomly. That looks pretty cool. And finally, just for neatness sake, and because I'm a bit of a neat freak, let's connect a null to the CopyToPoints output. And I'm going to call this one spheres out, and let's set the visible flag onto that. Let's come back to our object level and unselect everything. So here's our scene right now. And now if we play this back, again, nothing at all will happen because right now our spheres aren't connected in any way to this AutoDop network. Just like we did before, let's select the Geo1 node. I'm actually going to rename this to spheres. And let's come up into the rigid body shelf tools. And let's click on RBD objects. And this shelf tool will automatically deal with the fact that we actually created lots and lots of pieces of geometry. It's going to look a little bit different, but let's simply select the spheres node with all of our spheres and hit RBD objects. Let's unselect everything. And now if we play this back, all of our spheres will fall and scatter on the ground. If we jump into the AutoDop network for a second, and again press L and H to lay this out, over on the right hand side you will find a new node. This one is now not a cute little rubber duck, it's actually an RBD packed object which represents our spheres, but the principle is exactly the same. This essentially imports everything from this sub path that we have down here, from this geometry path, which is obj/spheres/dop_import1 into this network, then applies all of the physics, and that then exchanges it back and applies it back onto the spheres. So if you return to object and dig into the spheres node, again you will see that from our spheres out null object we have a rest position, which we had before as well, again just dealing with material sticking to the surface of the spheres. We then have this assemble node, which kind of deals with the packed primitives. And again, that's kind of a topic for another tutorial. It's getting a little bit complicated. But then in the end, we again just have this dop import, which exchanges data with the AutoDop network and then applies all of those transformations to all of the individual spheres. Let's one more time just rewind and play this back. And it looks pretty cool, but you know, it's just a little bit boring. All of the spheres kind of drop exactly the same way. It looks a little bit too uniform. Now, you may think, well, I can just come up into my object, dig into my AutoDop network, and on my spheres node, I can kind of come down into my initial state, and maybe we'll give them some velocity, again, in the X direction. Maybe we'll give them a 10 this time, and I'm pretty sure that'll do something. So let's, again, rewind and play. Yeah, well, it gave initial velocity, but it gives all of them the exact same initial velocity, which it just looks really, really odd. So let's not do that. So this is going to be the last thing I'm going to show you. I'm going to show you how to essentially apply different velocities or random velocities to all of these objects that we've created in our geometry node. You may have noticed that in this RBD packed object, same as with our rubber duck hero object, you have an option at the bottom to say inherit velocity from point velocity. This actually allows you to define a velocity attribute, as they're called in Houdini, and have different ones on all of these points for all of these spheres, and then the physics simulation will pick the velocity from that defined velocity, as opposed to applying the same velocity across all spheres. Each of them can have their own little velocity, which you define via an attribute. So first off, let's make sure we enable inherit velocity from point velocity, which will disable the velocity and angular velocity settings in here. If we play this back, nothing has changed yet because all of our points don't yet have a velocity. In order to do that, let's come back into the object level and dig into our spheres. And now it's going to get a slightly bit more technical. And again, there's much more to be explained in further tutorials, but just follow along. It'll end up looking pretty cool. So in our network, we start out with a simple sphere. We then apply a scatter to it to generate a number of points. And we then do a point jitter to kind of just shiggle them around a little bit so they're a bit more randomly distributed. Now in Houdini, there exists this concept of attributes, and you can have random attributes on points, on primitives, on detail, or on classes. It's quite an involved concept, but the easiest way to see the attributes on your points is to come to the bottom of the technical viewport and kind of pop this open. And this is going to give you the geometry spreadsheet. The geometry spreadsheet will show you all of the objects in your scene as well as their current properties. So let's make sure, right now I still have this dot import node selected, make sure we actually select the point jitter. And what we'll see in our geometry spreadsheet is we have a number of points, and these points only have a single property called P for position. So if I scrub through, it's 1000 points and all they have is a position. Now in our AutoDop network, we can adopt a velocity from the velocity attribute, but right now these points have no velocity attribute. We need to create that first. In order to do that, let's move the point jitter over and let's click on the connection between the point jitter and the CopyToPoints and hit Tab, and let's type attribute. Attributes are actually one of the core concepts within Houdini that really give the tool its power. They essentially allow you to define any property on anything you want and then to use that data to drive anything else, be that texture, color, transformation, fire, smoke, fluids, anything at all. So attributes are hugely powerful, which is why you have so many nodes to work with them. For example, there's an attribute create, and we could use this node to create a velocity. However, that would create the same velocity for every point. So the one we really want is an attribute randomize, which will both create and then randomize the attribute. So let's select attribute randomize. Let's drop that down. And you will see that all of our points have suddenly gotten really, really colorful. The cool thing is that these attributes will actually carry through. So if I now visualize my CopyToPoints, all of my spheres have gained that color, which comes from the point attribute. So this is actually really cool. And in the geometry spreadsheet, you will see that all of the points we have in our scene now have this CD attribute, which is the color. However, we don't really want the color, although you can certainly leave it and just make another one of these attribute randomize nodes. But let's select the attribute randomize, bring up the properties, and the attribute I want to create is called V. V for velocity. And let's hit enter. And you will note that immediately in our geometry spreadsheet, color disappeared, all of the spheres went back to gray, and we now have this V, this velocity vector defined. With our attribute randomize node still selected, let's come down to the bottom and let's change the min and max range of this random attribute from -5 across the board to 5 max. So now the velocity is randomized for each point between -5 and 5. So this is kind of our data that we're working with now. And the very last thing we need to do, and this just has to do with the fact that we're using a packed primitive here, we need to come into this assemble node. So let's select the assemble node. And down at the bottom, we need to make sure that we transfer a certain attribute, because right now our packed prims are kind of losing this velocity. In our rest, you will still see the velocity attribute for all of our points. So these are all of our points, remember. So they've got a position, they have a rest property after they've passed through this rest node, and they still have the velocity. Now if we go into the packed prims, all they have is a position and a name, so velocity got lost along the way. So in this assemble node, make sure that under transfer attributes, you add V into the list so that the velocity gets packed as well. Otherwise, your physics simulation will not have access to this property and it won't be able to use it. So now let's come back into our object level. Make sure you're at the beginning. Let's zoom out just a little bit. And let's collapse the geometry spreadsheet so we can see what's going on. And let's hit up to play back the final scene. And nothing happens. And this again, if you're new to Houdini, gets me every time. Let's come back into our spheres. What has happened is that right now we're visualizing, we're exporting the copy to points out of this geometry node. So we're not actually applying the DOP import data to our sphere. So let's come down to the bottom and make sure we're visualizing this DOP import node. Otherwise the physics data just won't be applied and nothing will transform and everything will just be static. So now let's return to our object level, unselect everything, and let's play it back. Cool! That looks much more exciting. So now what we have is we have a bunch of spheres, all defined by points. We could color them in and make them different sizes or give them different other properties. And they all kind of just explode in midair and then rain down to the ground. I hope this gave you a gentle introduction on how to work with physics in Houdini and at least gets you comfortable enough to start playing around with some of these shelf tools and some of the other stuff that you can do within Houdini. Obviously, there's still a huge amount of information to cover and we haven't even gotten to the really fun stuff, which is breaking things. But hopefully you did enjoy what you learned here today, and I'll try to get around to more Houdini tutorials soon. And that's all there is to it. I really hope you enjoyed this tutorial. If you did, I would greatly appreciate it if you could give it a thumbs up, favorite it, and share it with the world. If you do want to see some more good filmmaking and visual effects tutorials just like this one and you're new here, please consider subscribing. And as always, if you do have any comments, questions or suggestions, just leave them down in the section below. Thank you very much for watching, and until next time, I will see you later.